These notes are over chapter 4.2, energy changing forms. Okay, so on the start of these notes, you'll see that there's a bunch of different images, and we'll come back to those. First, I want to start with like the note part of this section. Okay, so mechanical energy is equal to our two main types of energy that we talked about in the last part, potential energy and kinetic energy. Okay, so kinetic energy, remember, is the energy of moving objects, and potential energy is just the potential to move. So it can either be like gravitational potential energy, so being higher up off the ground, you have a greater potential energy to be converted into kinetic energy and fall back towards the earth. Okay, or it could be like elastic potential energy, so the further back you pull a rubber band, the more elastic potential energy it has in order to convert it to kinetic energy and snap back to place. Okay, so energy is always conserved and transferred to different types. And so that's what we're going to talk about, the transferring of different types with all these different pictures. Okay, and so a lot of times it can actually convert back and forth between potential energy and kinetic energy. And so if you remember back in our other notes, this image here where you throw the ball up and then it falls back down, I kind of explained how it converts from kinetic energy where it's moving upwards till it stops and it has the greatest amount of potential energy, and then the potential energy converts back to kinetic energy. Okay, so we'll talk about how these different images also show the conversion between the different types. Okay, so one of the ways that energy is converted is that we actually get energy from food. Okay, and this is actual chemical energy. Okay, so we're breaking down food, we're breaking down the chemical properties of food and converting that into energy for ourselves. Okay, so 1 calorie is equal to 4.186 joules. Okay, but whenever we read food labels and you ask how many calories are, in this can of soda, the calories are actually kilocalories. So remember, kilo is 1,000 times the base unit. So if calorie is the base unit, kilocalorie equals 1,000 regular calories. Okay, so just an important thing to note there. Okay, so here below I have the different types of energy. I'm going to run through them real quickly, and then we'll talk about in the picture what types of energy we're seeing and how they're being converted. Okay, so we have thermal energy. So this is energy that's given off, you can kind of think of it as heat. Okay, radiant energy, this can also be known as light energy. So we get radiant energy like from the sun. Okay, chemical energy, this is when bonds are broken in order to release energy. Nuclear energy is like splitting of atoms and things like that in order to create massive amounts of energy. Electrical energy, these we get from things that are like plugged into electricity. There's a current of electrons that help cause this energy. A motion energy, that's going to be our kinetic energy. We have sound energy, so it's things that make sound. Elastic energy, we've kind of talked about before, and gravitational energy. So both of those are potential energies. Okay, so if we look at these different images, we can pick what the original energy is and then what's it converted to. Okay, so for this one, it would be it's starting as electric energy and then it's turning into radiant energy or light energy. Okay, for this one, again, we have electric energy and it's being converted into, you can say, thermal energy because of the heat that a blow dryer produces, or you can say kinetic energy because it's creating a wind-like situation, so it's creating motion. Okay, here, this one, a tree growing is what this image is supposed to represent. So it's taking radiant energy or light energy from the sun and it's creating chemical energy. Okay, so it's creating chemicals that we could later go and burn. Okay, here we have a car driving, so the gasoline is burned, so it's chemical energy, and it's converted into kinetic energy because the car is moving. Okay, the toddler eating, they're taking chemical energy, stored energy in the vegetables, so chemical energy, and then it's going to be converted into multiple different things. You could say kinetic energy, so it helps the toddler move, or you could say thermal energy because it helps to keep our body temperature at the correct heat. Okay. For this one, swinging, this is converting back and forth between kinetic and potential energy. Okay, so you have kinetic energy as you swing up, and then you kind of pause or stall out at the top. And that's when you have a lot of potential energy, and then it gets converted back into kinetic energy as you fall back down. Okay, here with cell phones, we have electric energy that's converted into, we could say, radiant energies because light. You could say sound energy if you're playing music. And then we have nuclear energy converted into electrical energy. Okay, so those are just some examples of the different ways. There could have been multiple answers for each of these. So it's just important to note that none of the energy is lost, it's just converted into something else.